Good evening, Kirtana.
Good evening, ma'am.
Have you tried to solve the last question that we have discussed? Kirtana,
Ma'am, your voice is clear.
just wait. I'm asking, and now is it clear?
Yes, ma'am.
Okay. I was asking that have you tried to solve the last question that we have discussed in the last class?
Yes, ma'am.
So, in the class when you performed, your answer was incorrect. So, did you redo it?
Yes, ma'am.
Okay. So now what's the answer?
KP is 60, ma'am.
Huh? No. This was the last class answer that you are saying.
No, ma'am. In last class, I got something. Oh, 1 minute. I got 48 or something.
Okay. Well, we have to discuss this question, right? So if we can see, our reaction is this one. Oh, I mistakenly written as N2O2. It is N2O4. This is my reaction, correct?
Yes, ma'am.
Uh, just wait, Kirtana. Just wait, Kirtana. Just a minute. See, in this question, total pressure at the equilibrium has been given to you me. That is 9.15, right? It means we have to play with pressure, correct?
Yes, ma'am.
We know that there is an equation that is PV is equal to nRT, correct?
Yes, ma'am.
Now, N how I can calculate this is the number of moles, means given mass divided by molar mass for N2O4. Like initially I have only N2O4 with me, right?
Yes, ma'am.
So given mass is 13.8 and its molar mass is 92. So my N will be 0.15. Kirtana, your video should be on.
Okay.
Correct? Actually, I have to find the pressure of N2O4. That what is the initial pressure of N2O4? So I can use this formula. So my pressure will be equal to what? nRT divided by V. Clear?
Yes, ma'am.
N is 0.15. R is what? As my pressure is in bar, so I have to take 0.083. And temperature is? What is the temperature that has been given to me? It is 400. Now volume. Volume is given to me, that is 1 liter.
Yes, ma'am.
So when I solve it, I get the pressure as 4.98 bar. It means this much of pressure has been present for N2O4 initially. Correct?
Yes.
It is 4.98. Take after time t, means at equilibrium, I can say that 4.98 minus some pressure was there
Yes,
because
ma'am.
this is consumed. 1 mole is reacting with to produce 2 moles. It means minus x is producing 2x.
Yes, ma'am.
Total pressure at equilibrium is 4.95. So I can write it like this, plus 2x. It will be equal to 9.15 pressure.
Yes, ma'am.
From here, I get the value of x, that is equal to 4.17 bar. Now I know this pressure at equilibrium and this pressure at equilibrium. I have the pressure of both the ones at equilibrium. Understood?
Yes.
Clear है ना? जहां पर नहीं हो आप पूछ लेना मुझसे. So it will be equal to this one and it will be equal to what? It will be equal to 8.34.
Yes.
If I have to write the formula for Kp, it will be NO2 का square divided by N2O4.
Yes.
So Kp is equal to NO2 कितना है? 8.34 का square divided by 0.81. Correct? And when I solve it, this will give me 85.87 bar. Means this is my Kp. Clear?
Yes.
One thing I have to calculate is partial pressure of the both the ones at equilibrium. So at equilibrium, N2O4 has a pressure this one and this one has this one, NO2. Correct?
Yes, ma'am.
The last thing that I have to calculate is Kc. I know that Kp is equal to Kc RT delta N.
Yes, ma'am.
So Kp is 85.87. Kc I have to calculate, right?
Yes, ma'am.
What is R? 0.083. Temperature is what? 400 and delta N is 1.
Yes, ma'am.
Clear? Is it clear, Kirtana?
Yes,
So
ma'am.
when I solve it, I will get the value of Kc as 2.58.
Yes.
Now the question is clear or still having any doubt?
No doubt, ma'am.
Okay. Next question for you. Now you got to know na, that how to solve the questions.
Yes, ma'am.
1 mole of water and 1 mole of carbon monoxide are taken in 10-liter vessel basically. And heated to 725 Kelvin. At equilibrium, 40% of water mass reacts with carbon monoxide. Accordingly, you have to calculate K equilibrium. Just try to do. Is the question is clear or
Clear.
clear है? Question is clear कितना? Do I need to explain? Kirtana, tell me, Bicha. Is the question is clear to you or do I need to explain? Kirtana, are you there?
Clear.
Okay, beta. Just try to do. Kirtana, your video went off. Kirtana? Kirtana, are you there? Kirtana, are you there? Kirtana, are you there? Are you there, Kirtana?
Yes.
Your video went off. Yeah. Have you solved the question? Have you solved the question, Kirtana?
Yes.
So what's your answer? What's your answer, Kirtana?
1.
No. See, let me tell you how to do this. In this question, I have a reaction. First step is to balance the reaction. I can see that my reaction is balanced, right? Correct now?
Yes.
At initially it is saying that I am having 1 mole of water and 1 mole of carbon dioxide. है ना?
Yes.
So at equilibrium, what will be there? 1 minus x. 1 minus x, it is forming x and x. I can write this one.
Yes.
Now it is saying that when we are at equilibrium, 40% of water reacts with carbon monoxide. It means if 40% is reacting, what amount we left with? 60%.
Yes.
है ना? So at equilibrium, I can say that this is my 60%. Correct?
Yes.
This is again 60%.
Yes.
And if 40% is reacting, then it means 40% is forming this one.
Yes.
Clear na? Now I have to write K equilibrium. So my K equilibrium will be what? H2 का concentration, carbon dioxide का concentration divided by water का concentration at equilibrium and carbon monoxide का at equilibrium, right? And it is 0.4 multiplied by 0.4 divided by 0.6 multiplied by 0.6. So 16 divided by 36. So it will be equal to 0.44. Clear?
Yes.
Question is clear to you? Now we have a constant that is K. Other constant is Q that we call as reaction quotient, on which basis we say that our reaction will proceed to the forward reaction or to the backward reaction, right?
Yes.
And one is we have G, that is Gibbs free energy, that tells us about the spontaneity of an reaction, right? So all the three have a relation basically. We know that when delta G is negative, then my reaction is spontaneous, correct? This we have discussed so many
Yes.
times. When my delta G is positive, it means my reaction is non-spontaneous, correct?
Yes.
So at equilibrium, what I can say that my delta G will be equal to delta G naught plus RT ln K.
Yes.
and that will be equal to 0 when my reaction is at equilibrium.
Yes.
Clear?
Yes.
It means if I am saying that at equilibrium my delta G is equal to 0 at equilibrium,
Yes.
I know that at equilibrium my K is equal to QC.
Mm.
है ना?
Yes.
So I can write my delta G naught is equal to minus RT ln K, as my delta G is 0.
Yes.
So my ln K will be equal to what? It will be equal to minus delta G naught divided by RT, or I can say my K is equal to e की power minus delta G naught divided by RT.
Yes.
Clear? So this is a relationship. Clear?
Yes.
One more thing I can interpret, when my delta G is greater than 0 means it is positive. At that time, if delta G is positive, my K will be negative.
Yes.
So my K will be less than 1.
Yes.
My reaction will be non-spontaneous. When my reaction is spontaneous means this one, at that time my K will be equal to, sorry, it will be greater than 1. So my reaction will be spontaneous.
Yes.
Clear? Hai?
Yes.
Now one question for you. Based on this concept, hydrolysis of sucrose gives Kc for reaction is 2 into 10 to the power 13 at 300 Kelvin. Now calculate delta G naught.
Ma'am, is it minus 276.23?
Kirtna, have you used the same formula?
Yes, ma'am. The R value I took it as 0.08.
No, bacha. In this one, we have, whenever it is mentioned that there is a pressure in bar, then you have to take 0.083. Otherwise, you have to take 8.314 always.
Okay, ma'am.
Okay. Any doubt in this?
No.
Okay. Now we will discuss about the factors that affect equilibrium. So basically, factors affecting equilibrium, or how we can change the equilibrium or any reaction. Basically, when we have to achieve the equilibrium, our main point is to maximize the product concentration, right? If we are doing any reaction, that we always tend that our product will be formed in maximum amount with minimum, we can say, expenditure,
Yes.
right? This is our main point na. So basically, how we can change the equilibrium, or how we can improve our product formation, it depends on a principle that we call as Lee-Chatelier principle. It is the most important principle. Sometimes it has been asked directly that what is Lee-Chatelier's principle. Lee-Chatelier क्या बोलता है? It says basically when our reaction is proceeding, okay, and if we change the concentration of something, like either of the reactant or of the product, the reaction will shift to that direction where the equilibrium should be achieved. मतलब अगर हमने कुछ भी चेंज किया तो रिएक्शन उसका अपोजिट साइड चेंज हो जाएगी, जहां पे हमें इक्विलिब्रियम जल्दी से मिल जाए. दिस स्टेटमेंट सेज दैट it states that you have to write the statement as such in the exam if I've been asked. Change in any of factors that determine equilibrium conditions of a system to change in such a manner so as to reduce or to counteract the effect of change. आया समझ? Basically, if we change any condition, our equilibrium shifts in that direction, so we can minimize the effect of that change.
Yes.
अगर मम्मा ने हमें 10 रुपए दिए, तो हमने क्या किया, फटाफट उसको खर्च करना शुरू कर दिया ताकि हमारे 10 रुपए किसी को दिखे नहीं.
Yes.
Clear? In the same way, Lee-Chatelier principle works.
Yes.
So first effect is effect of concentration. First we have effect of concentration change. Basically, if we have a reaction like A plus B and it is giving me C, If I increase the concentration of A plus B, like if I increase the concentration of reactants, अब reactant का concentration बढ़ गया तो मुझे इसको क्या करना है, कम करना है ना, right?
Yes.
So my equilibrium will shift in forward direction. अगर मेरा प्रोडक्ट का concentration बढ़ जाता है तो अब इसका concentration मुझे कम करना है.
Yes.
So my reaction will shift in backward direction.
Yes.
Clear? Question कैसे आता है? Question can be asked in this type of form, like what will happen to equilibrium when more 2SO2 is added to system and you have a reaction that is 2SO2 gas plus O2. At equilibrium it will gives me SO3. So in which direction your equilibrium will shift?
Forward direction.
Forward direction. Question, concept is clear that how the concentration changes the equilibrium.
Yes, ma'am.
Now we have effect of change of pressure. We know that we have an equation that is PV is equal to nRT.
Yes, ma'am.
So if we decrease the constant, like if we decrease pressure, P is directly proportional to concentration.
Yes.
Okay. So my number of moles will decrease.
Yes, ma'am.
है ना? So if I consider that I am having a reaction, suppose this one. This is my reaction. Okay. Here I can see I am having 4 moles. 1 plus 3. Here I am having 2 moles.
Yes.
Clear? Now I am decreasing the pressure. It means अगर मेरा pressure कम होगा तो मेरे number of moles भी क्या हो जाएंगे? कम हो जाएंगे.
Yes, ma'am.
My number of moles of the reactant is reducing. So to increase the number of moles of the reactant, what will happen? My reaction will shift to the forward direction.
Yes, ma'am.
Or I can say that when we change the pressure, so reaction moves towards greater number of moles. When we decrease the pressure, because decreasing the pressure, decreasing the number of moles.
Yes, ma'am.
Okay. And when we increase the pressure, number of moles will increase. My reaction will shift towards less number of moles. Suppose this is the question, like what will happen when volume is decreased and pressure is increased. Now you can see the reaction is this one. Okay. This is my reaction and I'm increasing the pressure. So if pressure is increasing, my number of moles will increase. Here I have 3 number of moles, here I have 2 number of moles. So when I increase the pressure, my reaction will shift to less number of moles, means my reaction shifts to forward direction. Right?
Yes, ma'am.
Clear?
Yes, ma'am.
Okay. Today we will do only this part. Just go through the above notes. If you have any doubt, then tell me.
Okay, ma'am.
And go through the numericals also once. That how we solve the numericals. Here, this one. Na? This we have started today.
Ma'am, can you scroll it? 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 Ma'am, can you scroll?
Just wait.
Ma'am, can you scroll? Done, ma'am.
Any doubt, Kirtana?
No, ma'am.
Pakka?
Yes, ma'am.
So your homework is you have to try the numericals based on the concept equilibrium, like in which we have to calculate the equilibrium concentration, either to calculate the Kp, Kc by using the equation Kp is equal to Kc RT delta N. Just
Yes.
try these numericals only. If you have CBSE now,
State, ma'am.
okay, so you can find the questions in your book also.
Yes, ma'am.
Okay, so just try to solve these ones, and if you found any doubt, then you can ask me.
Okay, ma'am.